All right, I'm going to go over this the first FRQ, which is the calculator FRQ. So start with the first part here. What does it tell us? It says got oil leaking from a pipeline of a lake on the surface of a lake and forms an oil slick whose volume increases at a constant rate of 2,000 cubic centimeters per minute. Oil slick takes the form of a right circular cylinder with both its radius and height changing with time. So what do we got? We've got the change in the volume is going to be equal to 2,000. It says change in the volume is 2,000 cubic centimeters per minute. Now, be careful with this. It says it's a constant rate of 2,000 cubic centimeters per minute. A lot of people put dV dt equals 2,000 T. That would be saying that the rate, this rate of change in the volume varies with the time. So the more time, the faster this rate. The rate will be increasing. But that's not what it says. It says it's constant. It's 2,000 throughout this whole time period. The whole thing we're concerned with, it's increasing at a rate of 2,000. The cylinder is increasing at a rate of 2,000 cubic centimeters per minute. Okay, what else does it tell us? It tells us this thing about the volume of a cylinder. A right circular cylinder is given by pi r squared h. And we can draw a picture too, right? We got a cylinder, looks something like this. It's real short, I'm guessing. All right, but it's big, and it's got a radius up here. All right, and it's got a height over here. Okay, looks something like that. All right, so I'm going to do part A now, and then I'll do parts B and C in different videos, because part A is actually takes kind of a while. Okay, so what are we told in part A? At the instant when the radius of the oil slick equals 100 centimeters, so r equals 100, and the height is 0.5, so height equals 0.5 centimeters, the radius is increasing at a rate of 2.5 centimeters per minute. So the change in the rate over time is 2.5 centimeters per minute. And at this instant, what is the rate of change of the height? So we're trying to find the rate of change of the height. So find dH dt, rate of change of the height at this time when these two things are true, when r is 100 and when h is 0.5. Okay, so let's keep moving then. All right, so what do we know? We know we've got dV dt, we've got dr dt. We want to figure out dH dt. Okay, well, we do have this. We're going to use this function and take the derivative of this. V equals pi r squared h. Let's think of that actually as two separate functions, because in a way it really is two separate functions. You've got pi r squared h. Now pi is just a constant. I'll lump it in with r squared to make things a little simpler. And then we've got another one, h. Those are two functions. Both r and h are varying on their own. So we don't have anything connecting those two right now. So we're going to have to, when we think about this, we're going to have to think about these as two separate functions. Now, we've got one function, pi r squared, times another function, h. So we're going to have to use the product rule. So maybe we can think of it like this. U equals pi r squared. V equals, actually I'll do this color, V equals h. Okay, well then u prime is going to be 2 pi r, but it's not just 2 pi r. It's 2 pi r times dr dt, because we're not interested in the derivative of v with respect to r. We're interested in the derivative of v with respect to t. So we're going to have to add on that dr dt at the end so that we get the derivative with respect to t and not r. Okay. Then when we go over here, we're going to get the same thing. Let me do this in the right color so that everybody's... So that's 2 pi r times dr dt. And then over here, we're going to get v prime. We're taking v again. We're taking the derivative of v, that's h, with respect to t as well. So we're going to get, well, 1 times dH dt. Now, what does the product rule say? Product rule is going to say that dv dt is going to be u v prime plus v u prime. So we'll get u v prime pi r squared dh dt plus vu prime, so h times 2 pi r dr dt. So I'm going to write it in this order just because this is how it started, times dr dt. Take the time to do this if that's not what you got. Take the time to do that because that's where you're most likely to make mistakes. Once you've got this, it's pretty straightforward because what do we want? Well, we want to find dv dt, right? Or no, we want to find dh dt. We know dv dt, we know r, we know r again, we know h, and we know dr dt. So we know everything except dh dt. It's just a matter of using the algebra to get everything in the right order. And when you do that, what do you get? You get dh dt equals dv dt minus 2 pi rh times dr dt over pi r squared. And when you plug in all the numbers and everything, you should end up with, I'm not going to write it all out because I'm kind of lazy that way. You should end up with 0.0387. And that's going to be right in centimeters per minute. And that's your answer.